Okay, today we're going to talk about types of organic reactions, and really this will be the beginning of a section of this semester where we look deeply into different types of organic reactions and some of them in particular. Now, there are lots of different types of reactions and organic reactions, some of which you've learned in Intro Chem. You heard of redox reactions and acid-base reactions, and there's lots of different categories of reactions, but we're going to start this discussion by just thinking of four of the main types of reactions that occur in organic chemistry: addition reactions, elimination reactions, substitution, and rearrangements. Now, we can describe each of these reactions with sort of generic reactants and products that describe their characteristics, and then what we hope is that you'd be able to look at any type of reaction and be able to determine what category it fits in. And the reality is some of the reactions that we'll be looking at have different steps to them, and each step of those reactions might be a different category of reaction. For example, there may be an addition reaction to form a transition state, a rearrangement of that transition state, and then an elimination to form the final product. But today we're going to just learn how to identify these things. Addition reactions are what they sound like. We have two reactants, A and B. One of the reactants is added to the other one to form a single product. We'll show an example of that and try to figure that out. Elimination reactions we usually think of as the opposite of an addition reaction. We have one reactant that breaks apart into two elimination products. Now, in organic chemistry, oftentimes one of those products is an alkene, and that's a clue for determining that something's an elimination reaction, is when you get an alkene product. Substitution reactions are where you have two reactants at least, and there are atoms or groups within those molecules which switch places. One substitutes for the other one. Here we have AB, that's one molecule, plus CD, a second molecule, and they form these products where C and B have really switched places. One has substituted for the other one. Okay. The final type of reaction we're going to talk about is a rearrangement. These are less common and a little trickier. Usually you have one reactant that turns into a product. That product has the same number and types of atoms because we haven't added or eliminated or substituted anything. It's just the way those atoms are connected is different in the product. That reactant has rearranged to form a different type of product. If you look at these, the generic equations for each of these types of reactions, you can see just by sort of counting the reactants and products carefully, you can really categorize a reaction into one category or the other. So let's try to do it. Let's add some reactions here and look at them. These are not in any particular order. We're going to try to match one to the other so that we can determine if we've learned what these categories are. Okay, so let's look at this first reaction up here and try to figure out what's going on. Okay, so this one's a little tricky. At first glance, you're like, well, here's one reactant and one product. But we have this sulfuric acid coming in as part of the arrow. So you might think of that as a reactant, or maybe it's not, right? Maybe it's just some sort of catalyst. We have to figure that out. And the way to figure out whether it's really a reactant or a catalyst is whether it is being incorporated into the product, right? Maybe this sulfuric acid is adding to this reactant and we have an addition reaction, or maybe it's not. So if we look here at the reactant and the product, we can see that the sulfuric acid isn't really found in the product, right? We don't have sulfur, we don't have any extra oxygens, and in fact, if you count the number of atoms in the reactant and the product, they're the same. They're just connected differently. And so this is a pretty classic example of a rearrangement. These atoms that are present in the reactant, some of the bonds have broken and reformed to rearrange into this product. You can imagine this carbon-carbon bond has broken and reattached to that nitrogen to give a bigger ring. That oxygen has formed a double bond, and the hydrogen has switched positions from the oxygen to the nitrogen. There's been a rearrangement that's occurring. So that's pretty straightforward. Let's look at this next one and try to categorize what it is. Well, the first thing to do is count. We've got one reactant, two products. One of those products is an alkene. This looks like a classic elimination reaction, and it is, right? We have this product that is sort of breaking into two pieces, right? One hydrogen and the chlorine is breaking off of the original reactant to form a new molecule. That's leaving behind an alkene. This is a nice classic elimination reaction. This reaction looks weird. It's complicated. And really, we're showing two steps here. We've got two arrows. Here's step one, where this goes here, forms this transition state, or really intermediate. This is really a transition state in this case. And this transition state then forms our final product. So let's look at the overall reaction and see what category it belongs in. Here are our two reactants, hydroxide and our alkyl halide, to form our alcohol and chloride product here. So we've got A plus B, C plus D. Just looking through here, that seems to fit a substitution reaction. If we think of this a little more deeply, we can see that it is a substitution. This hydroxide has attacked the carbon and kicked out the chloride. The hydroxide has substituted for the chlorine in the substrate here. So this is a nice substitution reaction. And then finally here, again, we have the multi-step reaction. Here we have an intermediate carbocation. But again, we can think of the overall reaction as A plus B going to one product, C. This seems like an addition reaction, and let's think if something was actually added here. Well, we can see that the hydrogen and the chlorine were added to this carbon backbone, right? This hydrogen was added to give us CH3. The chlorine was added to this carbon to give us CH2Cl. So we have a classic addition reaction there.